Hello guys, welcome back to another video. Today I'm going to show you a new workflow for video creation. Have you seen all these miniature tiny worker videos blowing up on Instagram and TikTok? More examples: 12 million views, 5 million views, 279, 26k. Let me quickly demo. It's not perfect because of the models that you choose and have to be cost effective as well. Folks are making pizza. So it has background music and also sound effects. And then if you, yeah, it's going through. You have a chopper. The prompt to generate images are a big thing. It's the images that are getting animated. You need to get the images right for the animations to properly work. If the images themselves have like distorted figures, then the animation is going to be distorted. A few more demos here. This is the background music is very faint. It's creating a clock, I think. Woodworkers. Alright, some magical land. You get the idea. The foundation of everything is the same. Just have to play around with different models and different API providers. Depends on how much you're willing to pay. We're using an ideation agent, which is an AI agent, to come up with the ideas. So you can enter your own ideas, or it will create its own ideas and write to Google Sheets. The ideas are split into different scenes, 5-second segments. Each of these 5-second videos are created from an image, and those images are created from a reference image so that the style across the whole video remains consistent. Using that reference image, we create the scene image. Then using that scene image, we animate the images using a video API like Kling or Minimax API or something similar. And you create sound effects. In our case, we are using 11 Labs, and for background music also we are using 11 Labs. A lot of people don't know it, but they think that they can only create sound effects with 11 Labs. It's not the best option, but it works for these kind of videos. And after that, once all the 5-segment videos are created, we stitch it up. We are not also using any of the paid APIs like Creatomate or JSON to Video. We have our own ffmpeg command which stitches up the videos, and finally we upload to YouTube and update the Google Sheet record to say this story has been published. So that's what we are going to look at, and let's jump into idea generation. So I'm going to show you the foundation of this, how to do this in an n8n workflow. If you don't know, it is an automation workflow tool which has been blowing up recently as well because of its AI agent first design. AI agents are native to n8n, unlike any other automation platform, and it is pretty easy to learn. It looks scary, but it's pretty easy to learn on how to create these workflows and stuff like that. So this is the n8n workflow that we are going to cover. The foundation of all these videos: you create a story and you create images for each stories, and you animate all these images. That will turn those images into videos. That's what we are going to have a look at today. If you are interested in more workflows and automations, check out my school community. It's called AI Makers. I will leave a link in the description below. I am documenting all these courses there. Let's dive in. Yeah, by the way, subscribe, and this is all AI generator, so subscribe to the channel and check out the school community if you want to learn more. A lot of information is shared here on YouTube. Yeah, if you want to learn about more automation workflows and stuff like that, we have faceless videos, social media agents, Reels repurposing agents, and keyword research and topic clustering for SEO, Reddit promotion. If you are like me selling SaaS products, you can promote those products on Reddit, and different kind of, you have long form article writer for SEO as well, and you have also a 3-in-1 lead generation cold outreach agent which automatically personalized emails to and find clients for you. Set it up, post it in the community, and get support. This is what we are working on right now. So let's jump into the workflow. First of all, you need to go to the community if you don't want to build it on your own, and you can download the JSON here. Otherwise, just follow along the tutorial and then you can build it on your own. It's not that difficult. Download it and the JSON will be downloaded, and go to your n8n installation, create a new workflow. Go to new workflow and then click on this import from file part and click on the JSON file, and the workflow will load, and open that up. What's in the ideation part? We are again using OpenAI to create the ideas and saving it to Google Sheets. Pretty simple. So we have a schedule trigger here, which just means that this workflow, when activated, will run on a schedule. Right now it's not running on schedule, it's all manual for me. So we have a niche and topics. This is actually not niche and ideas. I just copied it from a different workflow. That's why it's like that. So it's ideas. I'm giving an idea: tiny workers making pizza using excavators, helicopter, drum rollers, cranes, and other miniature world construction equipment. This is our own idea. So if you give that, other ideas are not going to be generated. The agent will only expand it. That is specified in the prompt. This is an ideation agent. I have named it as an ideation agent. What it is that it's an AI agent here. If you search for AI agent and click on AI agent, that's what will get inserted there. And you'll have to fill in all the prompt and everything connected to a model. So if you click on here, you select OpenAI chat model. That's how you connect the OpenAI chat model. And then you need to require specific output format for that fourth leg to appear. Currently it only have like 3 legs. And if you enable that, you'll have the output parser option, and then you'll have to select the structured output parser. What goes in them, I will explain it in a second. We have a think tool, which is not really necessary if you are using any of the reasoning models. If you're using non-reasoning models like GPT-4 mini or 4.1 mini, or even any of the DeepSeek models or any other models from a different provider, you can use that. Some of the reasoning models don't support tool calling, so a workaround for that is to use the non-reasoning model and attach the think tool to it. This is a tool from n8n, came out about 2 months ago, which basically mimics a chain of thought prompting. If you don't know what it is, gives it some space to think about stuff before coming up with the final response. It acts as a temporary staging cache where it can store its thoughts before it can come up with the response. That's what it is in simple terms. It's nothing complicated. You don't have to know the technical details of it, but that's how it will work. If you attach the think tool to a non-reasoning model, it will more or less work in the same way as a reasoning model. You will connect that to that. That's how that works. Let's go into the prompt section of it. So I have a big prompt here. You can screenshot this and ask ChatGPT to transcribe it. I'm just going to scroll it down. Yeah, if you download the template using the JSON, all of this will be loaded. But again, prompts for your specific workflow, you will have to adjust it according to your own use case. People just think that it's magical once you download a template, and it's only a starting point. You can create this kind of videos that I showed you how to create, but to fine tune it, you'll have to do a little bit of like prompt fine tuning. It's nothing complicated. You just talk to it like you would talk to an assistant, and then ask GPT itself to optimize the prompt. That's what I do. It will give you a better prompt. I'm not going to go through the whole thing, but I'll touch upon the main points here. You're a creative director. So a lot of my prompts, I structure it like this. Sometimes I have a task part here, but I don't have one in this one. This one just have role and context. So you're asking it to assume a role of like a director or a editor or whatever the task that you are asking it to do. I have an objective here: generate multiple whimsical, comprehensive process concepts. 3 to 5 different processes with detailed implementation steps for a 1-minute TikTok video. If the user has given a specific idea, then only expand that idea and create steps. Process category, select one only when the user's idea is not given. Otherwise, it will brainstorm to create manufacturing industrial processes, artisanal crafting, culinary arts, organizational systems, different categories. Based on that, it will try to come up with processes where it can go from a starting point to an end point where it will look like a process and you have a payoff at the end, so that the video itself is a bit more engaging. And visual appeal criteria, specifying no close-up scenes, so we want to capture a wider portion of screen, and dynamic movement, miniature charm. These are all ChatGPT written. I've just given the general idea and asked you to expand the prompt. Emphasize scale, contrast, tiny, miniature. This I have done. This I have manually written a lot of it here. Include all the sizes of all objects in all scene prompts for visual consistency of the sizes of objects in relation to the tiny workers. The process structure, create 6 sequential steps. That will mean 6 times 5 seconds clips, 30-second video in total. Emphasize a team of miniature workers. Build logically from start to completion. Maintain the narrative throughout the sequence. Each scene must have enough distinction from each other so that the image generation AI doesn't create 2 similar first frame images. So what are we trying to do here is that we are trying to create the first frame images for all the 5-second segments for each scene. Using that first frame image, it will create that 5-second segment. So each scene must have enough distinction. Be creative. For example, pizza making scene, use a drum roller to press pizza dough, and use a tiny world helicopter to transport pizza ingredients, etc. Image generation prompt rules: all images must include what the tiny workers are wearing, for consistency. The location where the activities are taking place, for example, kitchen countertop, environment elements, size of the individual objects, and remember these giants relate to the size of the tiny workers. Action figure or picture. The image prompts must describe giant elements. Important must create wide shots image prompts for the scenes, always emphasizing scale. It is always not possible because it's a portrait video, like a vertical video. And I have an example of a step generation, the scene generation prompt. Since we are using FAL AI here this is the FAL AI using Flux models from FAL AI. So Flux is a model, FAL is like a service provider. So this is what we are going to create our images. We are going to use Flux Dev image to image, and also we are going to use Flux Schnell for reference image, the first image. So that's a different model, but the same provider, which is FAL. For Flux, you basically give it in a conversational style. Be very descriptive, very instructional, but keep it succinct, but still instructional tone. And for each scene, it will create something like this. Create a wide over the shoulders at an angle, not directly from the top, at a kitchen counter where tiny construction workers are rolling, massive pizza, etc. Technical consideration for video generation animation prompts. This is for video animation, accepts like camera, like zooms and pull-ins and pull-outs, pedestal downs, ups, shakes, tracking, etc. Depending on which video generation API you're using, this may change. You will have to update this in the prompt. Some notes for the video generation camera movement system, and character limit constraints, again depends on the provider. Animation prompt maximum 2000 characters for the direction prompt. And we do also have a scene image video animation prompt, which is animate this scene with, as long as you create it in a very coherent format, instructional style, these models will work. Be specific, describe everything. We are also giving a required JSON. We want the generated ideas to be put in that JSON. Basically mean that give it in a certain format that it is easier to process. Otherwise it will be just like talking to ChatGPT, will give a text output which is harder to process. So that's why we are giving this here, and at the end we are adding a quality. We can add all these rules again at the end for it to check. We have a Google Sheet here, miniature videos. In that, let me just clear all the ideas here. This is where it logs all its activities, and I will link to this sheet in the description of the video. Make a copy of that and use it in the workflow. So let's try with our tiny workers making pizza. And that will create one idea. So we don't really need this. This is just for testing purposes. So I'm using GPT 4.1 mini for this. And in this model, add the response format as JSON. If you don't find that response format option, it's under add option, and just add the response format there and select JSON instead of text. And in the structured output parser, we are giving the same JSON that we have in the prompt here. Another thing that you have to do is sometimes the structured output parser fails. So go to settings and enable retry on fail, and then it will correct itself. So now we should have one idea here. The steps are in the JSON format as we have. You can see that in an app called jsonlint.com, and then if you go there and validate JSON, you can see that all the animation prompt, we have a number, we have description, step scene, first frame image generation prompt, scene image video animation prompt. We are also creating a sound effect generation prompt for each of these scenes. So we have 1, 2, 3, 4, 5, 6 scenes here, and each has its own sound effect generation prompt, which we will use with 11 labs to create the sound effects. Going back to the workflow, if you have a look at the process, let's click on that and it will show you the whole response. That is, as a schema, you have the process ID, the process, and create background score generation prompt. So this is the overall background music for the whole of the video, not the sound effects per scene. We have the sound effects under here as well. This split out node is simply splitting out that one item into multiple processes. Because we gave an idea here, it only created that one idea, and that will be like this, process ideas. And if you didn't give that, it will have multiple process ideas. So that will be split out into multiple process ideas to be written into the Google Sheet. So if I didn't give this here, let's remove that and run that again. It will take a while if you have multiple generations there. Now that is complete, you can see that we have 1, 2, 3, 4, 5 ideas. And if you look at the split out process here, we have 5 items now. And the thing that is coming from the ideation agent is process ideas and multiple processes. So we have the first one, miniature artisans crafting a giant grand piano. I'm going to pin this now, which means that the data output is pinned and will be used in the flow. Also going to pin this node so that we write stuff into Google Sheet again and again. So we have a miniature gardener cultivating a giant sunflower. First one is crafting a giant piano. Tiny workers restoring a vintage giant wristwatch. Miniature gardeners cultivating a giant sunflower. We will discuss creating the reference image generation next. Alright, let's have a look at the image generation portion of it. The first node here, so I'm just going to connect this to this limit node. Limit node is just for limiting the items coming out of the previous node. If you remember, we have 5 processes coming out from the previous generation 5 items, so I don't really want to create videos for all those 5 items. So I'm just going to select the first items or last items. Get only the first, just one item in the beginning. Let's disconnect that. The first node here, after that, let's disconnect this and let me show you how that works. If I execute, let's just start from here. Because it's pinned, it will always have all that data. And we can see that if you drag this to this node here, you can see just one item coming out of it. If you open up that node, you can see one item and the miniature artisans crafting a giant grand piano. That's what we are going to be processing. And this node itself is a HTTP node. So we have some idea generation. What happens there is that we are creating a FAL API request in that whole section, which will submit an image generation request to FAL servers. And because it will take some time, we'll have to do it in a loop to check for status. If it is complete, download the image. If it's not finished yet, wait for 1 minute. That's what this portion is, the whole section is. The first node is the HTTP request node. This is where you submit it to FAL. If you're wondering where I'm getting all this stuff, just search for FAL Flux or something. FAL Flux Schnell, which is the image generation model. You'll get the model page. You can play around in the playground here. Also, if you go to the API here, it will tell you how to submit a request and how to get the request status to see if it is finished or not, and also how to finally get the created images. Most of these file requests are basically the same. The URLs change. For example, if you are using Flex Dev, instead of that will be Flex Dev here. But all you have to do is come to the API portion of it and select HTTP curl option, and that will show you this curl command here. Submit a request, and I select that curl command. Don't select the whole thing, just select the curl command up until there. And if I go to my workflow, this is how you construct these HTTP nodes. I add a new node here, connecting from there, HTTP node, and then import curl, and paste that curl command there, and click on import, and it will create that HTTP node for you. Of course, you have to replace the FAL key with your own API key. If you don't have a FAL account, just go to FAL and sign up for here. Go to your account page, and there is an API keys option here, add key and create a key, and you will copy that and paste it into that key option there. That's how we do it. And the prompt is already pre-filled for you. You'll have to change that to expression. The prompt that we are going to use for reference image is the scene creation image for the first scene of the video. So that will be steps 1, scene image to video, first frame generation prompt. That's what we are going to use. Anyway, let me just delete that and show you in the actual HTTP request. So we have authorization key, everything is set there, everything will be pre-filled in. The prompt is simply the, if I expand that, you can click on that arrow there to expand that, and I am doing that. That's how that gets populated. And make sure that this is set to expression, otherwise it won't work. And also I'm giving an image size here, portrait 16:9, means that it is a vertical image that it is going to create. So that is that first node here. Once that is done, let me just run that node, and now it has submitted the request. So it says in queue, the request ID, request URL, status URL. So we're going to query the status URL here to check for the status. That's what that next node is. I'm going to pin that here so that I don't run that again. And in this node, it's again an HTTP node. Same thing, go here, API, check for status, and copy that curl command and create that node. Let me just execute that step, and the status URL here is the status URL from the previous node. That comes, you just drag and drop that there, which is the file node, and the status URL node here. That's what that is. And now it says it completed. If it was not completed, it will go through the wait section here. We have a if node here, and it just checks the status, which is completed, whether that is equal to, it will be a string, and so string and is equal to, and completed, I just copy pasted that there. If it is completed, then we can safely proceed to the next step. Otherwise, wait for it to complete. It is an 8-second interval. This is a wait node here, which is simply that node over there, wait node, and check the status again until it is completed. When it is complete, it goes on to the next node here, which is basically this URL here and the request ID from submit node. You'll get that in the status check HTTP node as well, which is the request ID here. You simply do that, and then you'll get the request ID. That's how that works. And now it is complete, and you'll get a images URL for the reference image that was generated. So if I check, that is not a tiny worker thing as well at all. So you'll have to play with the prompt a little bit. So I wouldn't proceed from here. What is the prompt that was submitted? Yeah, tiny picture style workers. Didn't really create it. There is our schedule trigger node. I'm going to unpin that. Yeah, the prompt needs to be there. So you can see that now it is waiting. Still no tiny workers. So what I'm going to do here is that sometimes it doesn't work at all. In the prompt itself, I'm going to code it here. Create a tiny worker scene containing as per the below prompt. Let's see if that works. Yep. All right. Okay. So that is good as per the below prompt, showing the scale of working with regular sized objects. Maybe that will make it even better. Yeah, so that will be updated in the JSON, so you'll have that. So these are kind of the tweaks that you have to do. A template that doesn't mean that it will work straight off the bat for all of it. You'll need to prompt it rightly, but it's a foundation. Now you know how you have to correct these prompts. Right off the bat doesn't work. I'm going to pin these things again. The get images node is another HTTP node, and that has the get result request here. Again, you need to pass in the authorization, etc. Copy the call. You don't have to if you are working with the template, and you just pass the request ID again, and then it will give you the image URL. And that's just a URL that you can type into the browser and then get the result like that. I like to see the images inside the n8n workflow as well. So I have another HTTP node here, view reference image, which will just download that. If you just drag and drop the image URL here, that's what that is, and then execute a get request, and you don't really need, because it's coming through CDN. Let's remove that. It should still work. So let's execute that again from here. Yeah, you don't need that for authorization to download the URL, because you can already access it through the browser. So that's that. Now we have a reference image to create all the scenes. I'm going to pin this actually just to speed up the process a little bit. So we started from the limit node. We took the prompt of the first scene and generated the image. We are using a split node here. What it does is that it splits these steps. So for each step, we need to run a image generation process and also video generation process. So that's why we are splitting it 6 times. The one item will be converted into 6 times. That's what that is. It's again a split out node, which is this node here. And in that, what you do is you just drag and drop that over there, and that's how you get that. Not so you already have a problem here. There is no generation prompt for the 5th image. Let's see what happened there. So if I go to our initial videos, the steps part, and copy that to JSON lint number 5, that doesn't have any. It doesn't have the step frame image generation prompt. Why was that? Because the ideation agent probably doesn't have it either. Let's copy that and put it here, validate it. Step 5, number 5. Yeah, the AI failed to generate it. I'm just going to recreate it with a better model. Let's disconnect this here, unpin this, and Mod 3 mini, and then I'm going to execute it from here. Save that. Now let's see what happens here. Let's connect that, and before doing that, we'll just go through this path. Let's see if it has all the prompts there. Yeah, that's much better. Maybe it is a good idea to add another check to see if all the scenes are available. All right, let's redo that part here, the image. So disconnect that. I think it's a clock making thing now. Pin that. You cannot really pin that because it has binary data in it. Connect this to the next section. I'm just going to connect it back to this merge node, and we need to merge that data with all the steps, which means that this reference image for the subsequent nodes, it will have both the information from the split outs. So because we have split into 6 items, this will be executed 6 times. If you didn't have this merge here, it will be executed only once, because there's only one item coming through this path. And then once that is done, don't pin that because that will lead to infinite loop. Now it's merging it. That means that you have the reference image plus all the steps from split out. That's input 1, and the input 2 is split out node. And if I connect to that, the next node, that will show me, not the limit one. If I select the merge node, it will have all the images. Let's see, the reference image here, and it is combined with the individual step data. Merge node, go to schema, similar thing, but because we are using a reference image, we are using a different model called image to image. So if I change that to image, you will be able to provide a reference image, and then you can prompt along with that reference image to create. So if I say a dog, that will change that reference image to a dog with the same colors and stuff like that. That's how that works. So we are using the reference image to make all the scenes consistent. And the same thing, go to API and have a look at how to submit the task. It's pretty much the same, only the URL changes, and the fetching the request status is again flex request. The same things. So I have changed that end image to FluxDev image to image, and I'm also giving the same authorization parameters. And in addition to the prompt, which is create a wide over the shoulder shot of an angle, not directly from the top, at a large drafting table in an industrial workshop. In the foreground, multiple teams of pigs are like tiny workers. For safety purposes, I'm going to just copy that hard-coded bit from the reference image and exactly the same thing before the prompt over there. So prompting Flux images is mostly human-like conversational instruction prompts rather than Midjourney-like prompts. So that's the prompt there. The image size is again portrait 69, which is the vertical image size. You can also add other parameters here. For example, num inference steps if you want more inference steps and stuff like that. I use the default values. You can add a guidance scale to influence creativity and stuff like that. For this, we are just going to use the defaults, and here's the same thing. So what happens here is that there's a rate limit for FAL. So we are firing all the 6 requests at one time, and in a loop we are checking the status, because we don't want to do the entire thing inside a loop, because if that's the case, you'll have to wait. It will take longer. You will fire one request, wait for it to complete, and then you will fire the next request, and so on and so forth. Instead of that, we are just going to fire all the requests to generate all the scene images at once, and then we are only waiting for the results to be processed. So they are done in parallel. So that's what that is. The next node is the HTTP node. It comes 6 items here, and then it fires it, and next it goes to a loop node, which is a split in batches node. Just means it's just a loop. I am giving the batch size as 1. So for each of these 6 items coming through here, 1 item will be sent through at a time. And for each of these items, let me just run this to show you how that works. And play this. Yep, there. Let me just pin that as well, so that it executes faster next time. And now it has fired all the requests and everything is in queue. So you can see that all of them are in queue. I'm going to pin that. In this loop, just going to disconnect it here. And in this loop, we are checking the status over here. So I'm just going to execute that step. The status comes back as completed, so it won't go to the wait portion of it. And similar to before, it is checking the status here. So I won't go through it again, and then there is a wait node after that. So I'm going to execute it until here. I don't want to kick off the video generation part yet, so I'm going to disconnect it from there and kick off the whole thing. We have an error. Get task. Could not load image from the URL. It's probably because, why is that? That is available. It's not coming through. It's available. So I'm just going to enable this limit node so that I don't waste money. Enable that, and I'm just going to is that the same for all? I'm not going to pin that. I'm just going to unpin that and see what happens. Unpin. Alright, I messed it up maybe. Image URL. Oh shit, I put the prompt in the wrong place. Okay, that's fine. So it has to be in the prompt section of here. All right, so let's just pin that, and this time you can see the wait node working through as well. Hopefully, let's just double check that the image URL is like there's no space or anything before that, and after that execute it once more, save it. All right, now let's pin that, and we do have get images here. Same concept as you do the get task, and that will give you the images. I have the image here, so that is working. All right, so I'm going to disable the limit node again so that we have all the 6 different scenes, and we can double check. Unpin that. That was actually pretty fast. FAL is actually pretty fast in generation, and see all the images that it generated. So the first one is like that, similar to the oversized gears and stuff like that they're working with. 3, a bigger factory, and you're working with different thing. And 6, they have done the finished the clock. Probably not the best idea that was generated by AI, but you get the gist of it. Maybe food videos are actually better to do for this. So now sound effects generation. The previous node for this is a split out node here. From the split out node we have each step coming through. If I look at the table here, each step coming through 1 2 3 4 5 6, and in each of those steps we have the scene sound effects generation prompt, and we are going to use that prompt and use it with 11 Labs API to create the sound effects. If you don't have an 11 Labs API key, go to 11labs.io and get your API key. So this is an HTTP node again. We are submitting a post request to that URL 11 Labs v1 sound generation, and authentication we are adding in the header parameter section. You have to enable this send headers parameter, or you can actually create an authentication credentials from here, which will not expose the keys like that, because that's not a good thing. Anyone can see it and it's not encrypted. These are the fields that you have to send in: the headers, content type, application JSON, and the XI API key. Notice that it's not authorization here, it is XI API key, and you have to enable send body and select using JSON and then open it like that. And the text is the video, the prompt, which comes from the previous step, which is scene sound effects generation prompt. That's what that is. If I include soft paper rustling, things like that, and the duration is 5 seconds, because we have to cover the 5-second duration of the video for the scene, the segment that we are going to create. And prompt influence is just like how much it should listen to the prompt, how much creativity it should apply. From here I'm going to connect it to another node called extract from file. So once this is done, it will come back with an audio file in a data binary format, but I don't want to store it anywhere. I just want to use it straight away from the workflow. So I'm going to convert that from the audio file format to a string format, which is why this node exists here. It's called extract from file, and you have to select this option, move to file to base64 string, and put it as data, and destination output field is sound effect base64. Let me just run that from there and see what happens. I have different images now. Better, I think. And let's see, the 11 Labs portion is finished now. Let's open that node up, and for each scene we have a sound effect. Let's go through that.
Include soft dawn.
We actually created the test as sound. It's not a sound effect, it's actually a person talking. That is incorrect. So the AI agent has a background music as well. Okay, so we need to adjust the AI agent here again. So in the ideation agent, I just changed the prompt to, I create an additional section here called sound effect generation rules, which is the clanging metal, soft industrial hums, and coordinated murmurs. So I just took the prompt that right one and gave it as a sound effect generation example. I'm going to run this portion again from the beginning, and I think I'll create a different idea as well. From here, I'm just going to ask ChatGPT for, or maybe go to our miniature videos idea and pick up one idea from there. Tiny bakers creating I'm just going to change it a little bit, saying picturesque tiny workers collaboratively mixing, baking, assembling, decorating a oversized multi-tiered cake on a kitchen island using miniature world 2 excavators, cranes, and other construction equipment and vehicle. I'm just going to copy that, and I'm going to really give it in our ID. I just had a helicopter as well. I want helicopter. Are there any other pins? Yes. Hopefully the sound effects generation will work fine now. I should probably switch back to GPT-4 with GPT 4.1 mini. Alright, it's proceeding to creating the reference image Let's see what it has created. What does it do now? Oh, it's a, yeah, okay. It is a cake baking thing now. All the images have been created. Once that is done, we'll move to sound generation here. Alright, moment of truth. Let's see. Alright, so all that has been created in the, all that is some sort of celebratory sound, and that's the sound effect generation section. And I'm going to disable this because you can't really pin the audio data from there, but I can pin the string, so I can pin that. And now we are going to have a look at the background music generation portion here. Same concept, it's just that we have the background music generation coming from the previous node, not from each of these steps, but from the parent record, which looks like this. So we have a process ID, process and background score generation prompt, and then steps inside of them, and the sound effects are inside of them. The background score generation prompt is at this level. So you're taking from that level, same idea, running through 11 labs, but this time we are setting the duration seconds to 10 seconds. Every 10 seconds will loop. That is the idea. You can create up to 22 seconds, but why waste credits? In these images, let's have a look at the images that it was created. View, not bad. Where are my helicopters? There are no helicopters here. Anyway, let's run this portion now, unpin this. Alright, now it has generated the background music here. Let's have a listen. Not bad. The prompt was a light whimsical instrumental score featuring gentle piano melodies, plucked strings and subtle percussions. Alright, that is good, and I'm just going to disable that again and pin the string version of it so we can reuse it. And after that, for the sound effects, we have an aggregation node. So we have 6 items coming through, and we don't want the subsequent part, which is this portion here, to run 6 times. So we are putting all the 6 items into one item. This is just an aggregate node. Let me just rename to aggregate and say all items data into a single list, and output in a field called segments and include all fields. We're going to do the same thing with the image video generation part as well once that is complete. So now we are going to look at the video generation part. Hopefully I have enough credits. Still, if I don't have credit and it fails, I'll just show you the previous video. I'm going to pin that from there, and I'm going to explain that. So again, we have a node from the split out, and the which 6 items come through here because we want it to run 6 times, and we want information that comes through split out node and also the image generation part as well. And we are doing a merge node over there, which is again mode combine by position, number of inputs 2, and include any unpaired items. Enable that. If you don't see that, just add an option and you will see the option there. And we have a loop the same way, but for Hailuo has a stricter rate limiting policy. So we are batching one at a time and then wait for 10 seconds and send the second request for the video generation. Rename that. The video generation API is this Minimax platform. So this is the Minimax account, which is their front end is Hailuo AI Video, Hailuo, and they do have a API access here. You click on there and that will take you to the API documentation, and then you apply for the developer program here, and they will give you, if accepted, you have to just go through the process and finish Google form, and they'll give you $50 credit. And they have this is their video generation part. They have an MCP. I'm not using the MCP, I'm just using the video generation API here, which is the creating a video generation task. Again, the same idea, change it to curl and copy the curl thing, come back to your workflow. For example, if I add an HTTP request here, HTTP request, and import curl and add that copied curl there and import it, it will fill in all the things, and then you will have to add your API key here, and also of course you have to change the prompt, which will be our video animation prompt. So that is that HTTP request over there, and I have my token there. Model is I2V01 director, which means image to video. T2V is text to video. Things like that's what that means. Director means that you can add camera movements in the prompt. So let me just check that and execute the workflow, and now I connected to the request. I should be able to see so it's coming as a PNG. This is the image that we have to, well, we don't really need that. If you go to table or schema, this is the image that we are going to use as the first frame. So that is the first frame image parameter there, and then you're adding that you're dragging and dropping the images URL over there. That's what that is. And you have the prompt is, as you can see, you drag and drop, animate this scene. This is the video generation part. You have the scene sound effect, you have the scene image to video animation prompt. That is what that is. Animate this scene with tiny bakers actively moving across kitchen island, pan left, which is the camera movement. Not all video generators support this. You'll have to go through the documentation. What I did was I just copied the documentation for these things and I put that in the prompt in the AI here. So you can see this camera movement system, stuff like that. That is taken from their documentation. And now let's execute the workflow. I will have it go through the whole thing and explain all the nodes. So now it is submitting the video creation request. Right, now it is going through this node here. It's going to wait until the process is complete. So in the meantime, let me explain what these nodes are. So now it has submitted everything and we have another loop after that, which is again a loop node split in batches 1. So that means that all of the 6 items one by one will be passed to the loop. And the first one is simply checking the status of the submitted task. That is the URL that you need to hit, which will be evaluated into task ID, and the task ID is taken from, you can't really see it because it is still running. Task ID is coming from here. Why is it empty? Maybe insufficient balance. Actually, you know what? I have some balance here in file. Let me just, you get this because as a bonus then. I'll do cling. It is expensive. It is like $3. And let's set it up. So what you need to do is go to Flux cling file video, and I'm going to do cling 1.6. I'm going to select, this is expensive. This is like 10 cents per second. So I'm just going to do a standard version of it. So cling file AI standard 1.6 image to video. Yeah, that is less expensive but lower resolution. I can live with that. API, and I'm going to copy the submitter request curl part here. Before that, I'm just going to copy the process of submitting a file request and replicate it here. And I'm just going to pin this. This will be our add a node shift cling AI video generation standard. In that we will go to the flex. Where was that? We'll copy that. You have to copy until the apostrophe, and instead of the image to image, remember we copied it from there. So instead of that, I'm going to import curl here and import that. Hopefully that works, or it gets stuck. Yep, it hangs. I'm going to wait. Yeah, this is buggy, the import word curl command sometime. I'm just going to manually copy it, and so the URL will be that standard image to video, and header we have all that, and prompt and image URL. It's pretty much the same thing, prompt and image URL. So I'm going to make sure it is actually prompt authorization. We already have that, and we have the prompt here, and we don't have image size because it's a video generation. And image URL, going to take that from the previous node that is coming through. So if I were to, I may be able to use it without this looping structure here. I'm going to connect that. Let's try with a limit first. One is the limit. Okay, execute flow. Right, now we have the limit, and I can now make sure that is coming through image URL. We need to change that. It needs to be, it's not a reference URL anymore. It is, I'm going to copy from the high-level image URL, JSON image URL. So the camera movements will not work. Maybe if Kling supports it, we shall see. Zoom in on her eyes slowly. So it's natural language in Kling. So now I'm going to disable the limit. Actually, I'm going to see with one image if it works, and then I'm going to fire everything. So it's the same thing. If there will be 6 items here, loop over each, fire the video generation prompts. Let me just rename to file click AI video, and then loop over all the results and waits until all the videos are complete, and execute the workflow and see what happens. So it's actually turning into a live build. All right, so we'll see. So that is in queue. Okay, so that's just one video. Takes a while. So the check state is showing still in progress. Maybe I should have waited more second for this one. Alright, that video generation is complete now, and let's have a look. We have the URL here. If I copy that and enter that, I think it's slightly better than Hailuo. They're actually working together and stuff. This guy is passing the dove to the hands are a bit weird, but that again, we are using the standard mode, the cheaper version of Kling AI. So keep that in mind. And now I'm just going to pass that. I'll actually add an HTTP node here to see what videos are being generated from there. So I'm going to get that. I'm just going to pass that URL there. It's just for convenience so that I can see the video in the workflow itself. Have pin that. What that means is that if I execute it once again, I will see the video right in the workflow. So in the get images, this was our image that was animated. So next one will be these ones here, and it's not really the video. Some have like orange outfits, some has orange aprons. I don't even know what these guys are doing. All right, now we have that HTTP. We can view the video here itself. So we will disable the limit there and execute the whole thing. Save it. If it is not super consistent, you can try this general LoRa, general image to image, rather than flex dev image to image, which is flex general image to image. So you're getting a lot of things from this workflow, image to image, where you can use control nets and stuff like that. You can add the mask like that and use that as a control net. And more examples, playground here, again the mask. You can even train certain LoRa's, and if you don't understand any of that, you don't have to use it. You just can use it with the image, just the image URL option still will be good. And yeah, let's fire this thing up. Now it is generating 6 video items. I am going to pin that. That is going to take a while, so I'm going to come back. So remember, this was 642 for us. So 7 videos. After 7 videos, that's 530. So 642 minus 530, about $1 for 7 videos. That will be 0.16 per video, about 20 cents per 5-second video. Or maybe this is not refreshed yet. It sounds too low though. Yeah, it's not refreshed. Sounds too low. So all the video generation is complete now for each segments. You can see here one by one. That is actually not so bad. There's a random head popping up from there. Oh my god, it's just walking over everyone. That is magic. Yeah, that is actually not a bad scene here. Last one is, I'm not sure what they're doing. So let's see what the damage is. Go to FAI. This one used to be 642. It was 642 before when we started the generation, and since then we generated 7 videos. That is 7 images. That is 22 cents, 23 cents per video, 5-second video. It still sounds a bit cheap than I thought it would be. Yeah. There is also a helicopter coming from somewhere. Look, there's our helicopter. Anyway, so that's it, and we are going to stitch all these videos together with the background music and sound effects now. So for that we need an aggregate node like this. I'm just going to copy that, and it needs to be in a variable called segments. Okay, so the aggregate node waiting to execute. So the aggregate node is finished now. You can see that it comes back in like this. You have a segments property, and under that you have video objects, which is slightly different from what the previous section was outputting. It needs to be segments video URL. The code node, which teaches this, expects the JSON to be in this format. So it needs to be segments and then video URL, sound effect URL, sound effect base 64. Either you can give a MP3 the URL for the sound effect, or a base 64 string, and a background music URL, and you have volume, sound effect volume, etc., volume control, and loop it false or true, background music looping. And by default it is true. We need to add a set node before here and convert that. When you add a set node, what we need is, from the get task, we need URL to be mapped. So we are taking the video URL out to be and putting that in video URL like that, and now it should be in the right format. If I save that and execute it, alright, that's finished now. So now it should be segments and video URL underneath. That should work properly like in the format here, but we're still missing sound effect and background music URL, etc., which we will combine it here. That is why we have this merge node here, so we are going to connect that to and that merge node, and let's do this here, make it a little bit compact. The sound effect has been generated, background music has been generated. Now we want to combine everything from all the branches. So the videos are coming from this branch, the sound effects, 6 of them are coming from this branch, and the background music, that is one item, coming from this branch. So we are combining the 6 items first. So this merge node here is combine all possible combinations. This one is just by position, so we want to merge it into the object. So let's delete that connection over there and then execute the workflow again. Now that one is merging, and now this one is merging. Alright, so we have that in the right format: segments, video URL, and sound effects base 64. And then at the end we don't have the background music, so we'll have to correct that. Oh, that's this merge node. So in the second merge node, it will add the merge background music and background music volume and sound effects volume. So that's coming from this set node over here. This one is simply background music volume. If you don't want the music volume to be that high, set it to a lower volume, and that is the sound effect volume. It's just like 2. So that's basically it. Let's try and add this to, instead of all possible combinations, by positions and 3, that will be this line here. So that is how that background music and sound effect gets merged. And I do already have a pin data here. Let me just pin that and connect it to the FFmpeg, a code node here. This is a, if I go to code, that is the code node over there. That is the code inside. Simply, it's an FFmpeg command, which is a command that does video processing. For that to work, you will need to have FFmpeg installed on your server. In my case, I am deploying this on Hetzner servers, a virtual machine, VPS, with Coolify. So I'm just doing this on Coolify, and select that n8n container, and then add apk add ffmpeg, no cache. And if I run that, that will install that in that Docker container. You can do the same thing with Railway installation or DigitalOcean. I have explained this in a previous video where I talk about the YouTube long form video creation. And now it is time to execute the rest of it. Let's connect this back again here and execute the workflow. Yes. So that is a code node. First it creates an ffmpeg command. It will be in video stitch details. In that is a temporary directory where all the files will be stored, downloaded sound effect parts, and there will be ffmpeg command property here in the schema. If I go to video stitch details, it will output this content here, the code node. We have the temporary directory where it is working. So this is on a VPS, and these are all the video, downloaded video parts, and it will give you an ffmpeg command, which is then passed to this execute ffmpeg. So this one is creating the command, this one is executing it. For this to work properly, you'll have to enable this environment variable here called node function allow built-in. You'll have to add this and set it as a build variable, and fs, dps, path, os, crypto URL, all this needs to be added so that the runtime has access to the node runtime and its packages. These packages are used in order to create the ffmpeg command, download these files to file system, etc. Make sure that is in your Docker Compose file like that. So that will look like in your, if you have installed using Docker Compose, that will look like that. Node function allow built-in. And now it has executed the code. The execute node has executed the ffmpeg command, and we have a read write node after that. So that has executed it and created the video, and we have to read that from the file system. So for that we need this read write files from disk node, and what we are passing it is the generate ffmpeg command 2 nodes back. Before this execute node, it has a output URL. So here in the video stitch details, it has an output path. That is this output path here, and once that is run, it reads from the file system. Remember, this is stored on the VPS, and you can view that. Alright, so that is our video generator. The last part is uploading to YouTube, which is basically HTTP request node. This is simply an HTTP node, and the URL is like that. We need to first create a container so that we can upload videos to that container, because it's a resumable upload, which means that it can get interrupted, but you can try to upload it again. That is how YouTube handles it. So the first one is actually creating a sort of like a placeholder, making it ready to receive the video file. So that is that upload link. This is a post request to that URL and predefined credential type and YouTube auth to API. In that, you'll need to create a credential, and you'll have to create the client ID and client secret similar to what you did for Google Sheets. You'll have to go to cloud.google.com and then go to your console and create a project here, and in that we will have to, in the APIs and services section, you'll have to enable data API. Yeah, you need to enable YouTube data API there, and after that you'll have to create a credentials, create a client. I have created a n8n connection. It's pretty straightforward. Once you create credentials, auth, client ID, and application type is web application, and then you add the URI here. This URI would be the URI from here, but not the whole thing. That will be just this part, remove that part, and then authorize redirect URLs, the whole thing, and then save it. And once you do that, you will get the client ID, and once you click into that, you will see the client secret. And copy those two, and come back here, and in the YouTube account link, create a new credentials, add the client ID and client secret there. That's how that works. Once that is done, follow these send headers. There will be application JSON, XUpload content type, that will be video WebM, and then you have the body type is raw and raw JSON, which will look like that. Title, I'm just taking the process description from the limit node and limiting it to 50 characters, and the description is basically the same thing without the limit. And tags, category IDs, I think 24 is entertainment, and privacy status is private, so that it wouldn't appear immediately once you upload it. That's what that is. And once that is done, I'll have to refresh my credentials as well, because somehow that is lost. So now that is done, we have a merge node here. The merge node is simply getting the data from, for the YouTube upload to work, the node just before that needs to have the data property, and this is a node that has a data property which has the actual file in binary format. This only accepts the actual file, not the video URL. There's a way to do that. It's a bit more complicated. This is the simplest approach, so that is why we are adding a merge in between, not directly passing the video to the upload link here and then redirecting it. So it needs to be just right before the YouTube upload node, so that it has access to the data field which has a binary video. This is with combined positions by number of inputs. One is coming from the YouTube upload link, and this path over here is simply coming from the limit which has the YouTube title and description. So that is coming from the process, the JSON process. That's what that connection. And finally we have a Google Sheet. Again, the same thing, same Google credential. You can use the same client and connect it. After that, what this does is it takes the process ID that we have stored. It just updates the logs for that process ID, whichever one we were trying to create, and sets as published or uploaded as the miniature videos sheet, that sheet over there, and the ideas worksheet, which is this ideas over here. And once you add your credentials, this will auto populate, and then you can just select like that. And the operation is update row, and mapping column mode is manually, and we are using the process ID column to match on, and the process ID is read from the limit node that is coming from the path, and status is uploaded, and the video link finally is taken from this node will spit out the video link after the upload is finished, and that will be stored there. So let's execute this portion, and then I'll show you once again. Saved, execute. So now it is uploaded, and if I go to my YouTube account, it's a different account, this one here, that is uploaded here, Tiny Worker. These are all the testing thing that I've been doing. Which one did shorts? There it is. Whoa. So that concludes our workflow. Again, all the prompts and everything is in our school community somewhere over here, and I'll be publishing this, and you have already all the other agents also. I'm adding more and more agents here and workflows, and all the other links also will be in the description. Check it out. Let me know what you think about this. Also, I wanted to mention that there is a version free image generation. This may be a little better for style consistency, but it takes a long time to execute. That's why I commented it out, but it takes these styles seriously and the images are much more consistent. Also, you have a different image model here, which you can use control nets and LoRa's, etc. You can use it for different use cases. Just including it here. I was testing all of them while creating this workflow. So try connecting. For this to work, just delete this and connect it to here to test it out. That's how that works. Try it out, and I'll see you in the next one.